Hi, Gil from Testing Gil here. Let me tell you about how I built a machine to stop my AI from cheating, and then how I went around this machine. As a developer, I sometimes look at my code a month later, just kidding, 3 days later, and think, I could have solved that a lot simpler. And as a tester, I smack my developer self in the head and say, yeah, you should have. It would have saved me a lot of time. Yes, developers can make simple things very complicated all by themselves. But why do it alone? Bring a genie along. We talked about how non-reproducible behavior makes testing a lot harder. But it looks like we can do a lot worse. Remember my TDD problem? Here's a recap. In TDD, you write the test first and make sure it fails. This is called the red phase. Then, you fill in the code to make the test pass, refactor if needed, and move on to the next phase. My problem was that the agent was skipping the red phase, creating a test that fails, and improving the prompt didn't make it better. So, what else could I do? Well, if you want to make the non-reproducible reproducible, you need to move the parts you want into real code. And here where things became a lot more complex. I have now integration between code and prompts. But who's running who? It's not just a design question, it's a money question. If the main prompt runs the code, it comes out of my AI package. But if the code runs the prompt, it comes out of the API's budget. But I wish it was that simple. So Claude suggested we build a state machine script. And the script was built with tests, some of them test first. And I decided that the prompt will run the code, which still didn't solve the problem completely. It was still up to the genie to decide which rules to run. So how do you make a genie play by the rules if it can change the rules? What happens when you have two enemies that need some mediation? You get a third party involved. You get an enforcer. In my case, it was Git, and a file containing the current state that was committed every sub-step. Now, Claude could not skip steps and could not change the state. You see how simple things become complex? One more enforcement was a hook that didn't allow Claude to change the script. I didn't actually get it red-handed trying to change the script, but it suggested the idea. So I guess at least one of us was thinking about it. Now, add one more complexity layer on top. You think it's just code? Nah. There's a reason we like simpler solutions. If we need to make changes, and we'll always need to make changes, simpler things are easier to change. What do you think happened when I needed to make changes to my TDD machine? By now I had it running red, green, lint, and coverage, 4 steps. All the steps that I needed. But then I discovered something I already knew. Sometimes I add an end-to-end test. And this test doesn't require changing code, because it goes over already tested code. It's not strict TDD, but it's real-life app building. Stop, the state machine says. You can't do that. The test must fail first. But, our state machine was missing a state. Claude, fix it. And Claude said, I would do this for you, but I can't touch the script. I promised. Unless, of course, you'll let me do this just once. And I did, once, or 5 times, maybe more. And I couldn't stop thinking about the genie, somewhere up there in the cloud, laughing at me. Because I wanted it to play by the rules that I now broke myself. Anyway, my point is this. We all should strive for simplicity. It lowers the cost of development, of testing, and of maintenance. But on the other hand, we're letting the complexity monster into our living room. We're letting it play with our code and make us work harder. And in some cases, live with the risks that it introduces. So, was it worth it? The enforcements, the state machine, the gits, and the hook are still there. I'm just making them lighter. Because in this case, what was important for me are the following of the TDD rules. It made sense to enforce them. With the rules in place, I get code that I can verify, run, and trust. But it is a complex solution. And I experienced it that any complexity makes changes harder. Harder to make changes, harder to verify them. You know, Dijkstra said, the computing scientist's main challenge is not to get confused by the complexities of its own making. It's still his own making. It just gets help now. Now, tell me about a rule you put in place and then broke it yourself. What made you break it the first time? Thanks for watching. If you like this video, like, subscribe, share it, and watch other videos on this channel. Until next time, bye-bye.